Hello everyone, welcome to SimpliCode. This is the second part of our NumPy tutorial where we will cover some more concepts and operations in NumPy. You can find the link to the first video in our description. Please watch the first part before proceeding with the second part. Richard is with us and he'll be leading the session. So let's move ahead.
So last time we covered part 1 where we went over the difference between the Python array and the NumPy array and why it's both easier to use, uses less memory and resources, and is also faster than the Python list. We also went over a number of the basic features in there, like looking up the min, the max, the median, how you can go ahead and create some very basic arrays, fill them all with zeros, fill them all with ones, look up the size, the shape. So we covered a lot. We covered a range, which is equivalent of Python, well, sort of the equivalent of Python list range. And then we looked a lot into characters and working with the NP character and how to capitalize, center it, change it to a title, lowercase, uppercase, splitting, stripping, joining, and replacing characters. So what's in it for you? Today we're going to go over array manipulation. We're going to go over NumPy, arithmetic operations, slicing arrays, iterating over arrays, array concatenation, splitting arrays, NumPy histogram using matplotlib, and a few other useful functions in the NumPy. And then we'll do a practice examples at the end. And hopefully you've already got your Jupyter notebook. I like to use it through Anaconda, but certainly you can just use a direct Jupyter notebook. Now let's go ahead and dive in there since we're going right into part 2, which is getting some coding going under our belt. And here in our Jupyter notebook, we can go under New and create a new folder, Python 3. I think I forgot to do this last time, but we could just do the Control++, which in any browser enlarges a page, makes it a lot easier to see. Always a nice feature. Another beautiful benefit of using Jupyter Notebook. And let me go ahead and show you a neat thing we can do in Jupyter. This is nice if you're working with people and you're doing this as a demo on a large screen. I'm going to do the hashtag or pound symbol array manipulation, kind of a title of what we're working on. And then I'm going to call this cell type markdown as opposed to code. And you'll see it highlights it here, and then if I run it, it just turns it into array manipulation. And then we're specifically going to be working on array manipulation, changing shape to start with. And we'll go ahead and mark this cell also a markdown, so it has a nice little look there. And then it comes up, and you can see it, just like I said, it just highlights it and makes it in bold print, just making it easier to read. Not a Python thing, but a Jupyter thing that's good to know about, especially if you're working with the shareholders, since they're investing money in you. Of course, the first thing we do is import. We're going to import NumPy as in P, and that should be standard by now. By now, you start a Python program, you're doing some data science. NumPy is just something you bring in there. And let's go ahead and create our array, and we're going to do that as the np.arange. Remember, that's 0. Well, we're going to do 0 to 9, and then we'll go print. Put a little title on the original array. We'll just print that array A. Remember from the first lesson. So we have our array, which is 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's add a print space in between. Let's create a second array, B, but we want this to reshape array A. And what does that mean? And the command is simply reshape. And then we have 9 items in here, and this is so important right now. So be very aware, if I did some weird numbers in here, it's not going to work. And we want multiples of 9. We know that 3 times 3 is 9. So we're going to reshape our A array by 3 by 3. And then we're going to print, well, let's give it a title. Oops, I had too many brackets in there. Modified array, and then let's go ahead and print our B. And let's see what that looks like. And as we come down here, you can see we've taken this and it's gone from 0, 1, 2, 3, 4, 5, 6, 7, 8 to an array of arrays. And we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we split this into 3 by 3. And you can guess that if I tried to reshape this, let's just do a 5 by 3, which is 15, that's going to give me an error. So it's not going to work. You're not going to be able to reshape something unless the shape, all the data in there matches correctly. So we can take this flat 9, and we call it a flat because it's just a single array. And we can reshape it into a 3 by 3 array. And first you might think matrices, which this is used for that, definitely. I use it a lot in graphing, because it'll come in that I have an array that's xy, comma xy1, y1, comma x2, y2. And so the shape of it might be 2 by the length of the number of points. And I need to separate that into X flat array and a Y flat array. And you can see this can be very easy to reshape the array doing that. And we can of course go back. We can do B, do a print, and we'll do B dot flatten. Remember I said it's called a flatten array? And if we run that, you'll see it just goes back to the original one. It takes this 0, 1, 2, 3, 4, 5, 6, 7, 8 and flattens it back to a single array. And then one other feature to be aware of is if we flatten it, one of the commands we can put in there is order. Let me just go ahead and do that. Order equals F. Strangely enough, F stands for Fortran. The whole Fortran days. I remember actually studying Fortran programming language. In this case, you'll see that it uses the first, like 036 is the order. So instead of flattening it like we had before, 0, 1, 2, 3, 4, 5, 6, 7, 8, it now does 0, 3, 6, 1, 4, 7, 2, 5, 8. And if you go to the NumPy array page, you can see here that they have the flatten. I just open up the NumPy ND array flatten setup to look it up. And they have 3 different options. They have C, F, and A. And it's whether to flatten in C, which was based on how the C code works for flattening, originally worked, which is row major, Fortran, which is column major, or preserve the column Fortran ordering from A. So whatever it was in, the default is the C version. So the default that you saw, you could put order equals C and it'd have the same effect as we saw there before. You could even do order equals A. That would also have the same effect because that's the default. So really the only other thing you really should change on here is to change it to C if you need it. And you can see right here, or F, I mean not C. The only thing you really want to change it to is to your F for the Fortran order, which then does it by column versus by row. And let's look at, here we go, reshape. So let's create a range of 12, and let's reshape it. And we'll do 4, 3 for this one. And remember this is NumPy. I forgot the NP there. np.arrange. And we can type in just A for print, or you can do full print A. And of course in Jupyter Notebook you even have a little extra print at the beginning. When we run this, we'll see we create a nice array of 0, 1, 2. It's reshaped it. So we have 4 rows and 3 columns, or you could call that 3 columns and 4 rows. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But this one is so important. We'll do np transpose A. And let's go ahead and run that. And it helps if I get all the S's in there and don't leave an S out. And you'll see here we've taken our array. If you remember correctly, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've swapped it. So we've gone from a 3 by 4 or a 4 by 3 to a 3 by 4. And this really helps if you're looking at like a huge number of rows and the data all comes in. Like let's say this is your features in row 1, your features in row 2, and this is X, Y, Z. Well, when you go to plot it, you send it all of X in one array, all of Y in one array, and all of Z in another array. And so it's really important that we can transpose this rather quickly. This is kind of a fun thing. I can highlight it and do brackets around it, and if you remember correctly, because we're in Jupyter, it doesn't matter where we do the print or not. It'll automatically print it for us. And you see if I hit the run button, it comes up with the same exact thing. And let's play with the reshape. And you know what, let's zoom this up a little bit here. Make that even bigger so you can really see what's going on. And let's play with the reshape just a little bit more. We'll do B equals np.arange. Let's do 8. And reshape. We'll do 2, 4. Let's go ahead and print B and then run that. And you'll see we have now the 2 rows. This is a bit more like, so we have 4, maybe 2 rows of 4 things. So this might be all of our X components and our Y components. So we can switch it back and forth real easy. Important to note here, whether we do 2, 4, or in the case of 4, 3, this has 12 elements. And so however you split it up, it's got to equal 12. So 4 times 3 equals 12. That's pretty straightforward. Same thing down here. 2 times 4 equals 8. If I change this, and let's say I do 2, 3, let's just run that in, and you'll find we get an error because you can't split 8 up into 2 rows by 3. You have to pick something that it can split up and arrange it in. So let's go ahead and run that. And just for fun, let's go reshape our B again, if I can type. Reshape our B again. And what else goes into 8? Well, we could do 2 by 2 by 2. So we can take this out to 3 different dimensions. And then, if we, because this is going to come out as a variable, we can just go ahead and run it. And it'll print it. We could also do a print statement on there, just like we did before. And you'll see we have 2 different groups of 2 variables of 2 different dimensions. So 2 by 2 by 2. And let's go ahead and assign this to a variable. C equals B reshape. And let's do something a little different. Let's roll the axes. Roll axes. And we'll take our C and do 2, 1. And if we go ahead and run this, it's going to print that out. Whoops. Hit a wrong button there. Let's do that one again. And you roll the axis, and you can see that we now have, instead of 0, 1, 2, 3, 4, 5, 6, 7, we now have the 0, 2, 1, 3, 4, 6, 5, 7. So what's going on here? We're taking and we're rolling the numbers around, and let's just simplify this. We'll just do it with C, 1 and run that. And so if we roll a single axis, you got 0, 1, and then it rolled the 4, 5 up, and then we have 2, 3, 6, 7. And if we do 2, let me see what happens there. And this is one of those things you really have to play with and start feeling what it's doing. We've now taken 0, 2, 4, 6, 1, 3, 5, 7. So you can see we've now rolled by 2 digits. Instead of rolling the 1 setup, we now rolled 2 digits up there. And so if we go back and we do the 1, so we've rolled it up, 0, 1, 4, 5. And then we're going to take the 2 in there. And we've rolled the 0, 1, 2, 3, 4, 5, and 6, 7. So we start rolling these things around on here. There's a lot of different things you can do on this. But it's another way to manipulate the numbers on your NumPy. And finally, let's go ahead and swap axes. We'll do C. And let's just go ahead and run that. It's going to give me an error on there. That's because it requires multiple arguments. Left out the arguments. So now we can swap them. We get the 0, 2, 1, 3, 4, 6, 5, 7. So you can see everything's been swapped around. So next thing we want to go over is we want to go over NumPy arithmetic operations. How can we take these and use these? Let me just go ahead and put this cell as a markdown. There we go. We'll run that so it has a nice thing. Alright, nice title on there. That's always helpful. And let's start by creating 2 arrays. We'll do A is an NP range, A range 9. And let's reshape this 3 by 3. So by now you should be seeing this reshape stuff, and this should all look pretty familiar. We have our 0, 1, 2, 3, 4, 5, 6, 7, 8 on there. And let's create a second one, B. And this time, instead of doing A range, let's do NP array. We'll just create a straight up array. And we'll do an array of 3 objects. So it's going to be 3 by 1. And if we go ahead and print B out, we run that. This is actually pretty common to have something like this, where you have a 3 by whatever it is and a 3 by 3 array. When you're doing your math, you kind of have that kind of setup on there. And what we can do is we can go np.add AB. Don't forget, we can always put a print statement on there. So if we add it, you'll see that it just comes in there and it goes, okay, we're adding 10 to everything. And we could actually do something more, make it more interesting. 10, 11, 12. So let's change B's, now 10, 11, 12, and let's run that. And you can see that we have 10, and then you had 1 plus 11 is 12, 2 plus 12 is 14, 13, so 10 plus 3 is 13, 11 plus 4 is 15, and 12 plus 5 is 17, and so on. We'll put this back, since that's how the original setup was. Let's do 10 by 10 by 10, and run that, and get the original answer. And if you're going to add them together, we need to go ahead and subtract AB, and we run that. We get minus 10, minus 9, minus 8, just like you would expect. So we have our subtraction. 0 minus 10 is minus 10, and so on. And if you're going to add and subtract, you can guess what the next one is. We're going to multiply. And we'll multiply AB And this should be pretty straightforward. You should expect this. If we multiply 10 times 0, we got 0. 10 times 10 is 10, and so on. And finally, if you're going to multiply, what's the last one we got is divide. What happens when we do divide a by b? And we run this, and we're going to get 0. And this is 0 divided by 10 is 0, 1 divided by 10 is 0.1, 2 divided by 10 is 0.2, and so on and so on. So the math is pretty straightforward. It just makes it very easy to do the whole setup. And again, if we went this, and let's say, let's change this up here. Instead of 10, we do 100. And make this 1,000. There we go. And if we run that, and then we do the add, you can see we got 10 plus 100 plus 1,000. Same thing with the subtract. Same thing with the multiply. And then you can also see the same thing here with the divide. So a lot of control there with your array and your math. Again, let's set this back to 10. Oops, it's right up here, wrong section. There we go, 10. And we'll just go ahead and run these and get back to where we were. And this brings us to our next section, which is slicing. And let's put in our, we'll just make this a cell type markdown. And then we run that. Of course, it gives us a nice looking slicing there. And the slicing means we're just going to take sections of the array. So let's create an array np a range. Let's just do 20. And if you remember, if we do a, we have a 0 to 19. And then we can do a, and remember we can always print these. This can always be put in a print, but because I'm in Jupyter, if you're doing a demo in Jupyter, it's just so great that you have all these controls on here. So we can slice 4 on, and this should look familiar because this is the same as a Python and a lot of other different scripting languages. If we do 4, it goes 0, 1, 2, 3, that's the first 4 in the thing, and it skips some and starts with this one. The first 4 are skipped, and then from there on. You can also do the opposite and go till the 4th one. If we run that, we get 0, 1, 2, 3. Quite the opposite on there. We can do a single item, so we can pick object number 5 on the list, run that, and 5 happens to be 5, because that's the order they're in. And then this one's interesting, because I can do s equals slice, and let's create a slice here, and let's do 2, 9, let's leave a 2 on there. So we'll create an s slice on here. And then if we take our array, and we do array of s, we're taking our slice in there, and let's go ahead and run that. And let's take a look and see what it generated here. First off, we started with 2, so we have 2 at the beginning. We're going to end at 9, which happens to be 8, so it stops before the 9. Remember when we're doing arrays in Python. And then we step 2, so 2, 4, 6, 8. We could do this as 3. Let me run that, and you can see how that changes, 2, 5, 8. And we could do this as, let's leave this at 3, and if we change this to 10, oops, let's make it 12, there we go. And we run that, we have 2, 5, 8, 11. So that's pretty straightforward. It's a very nice feature to have on here where you can slice it and take different parts of the series right out of the middle. So now that we've access to different pieces of our array, let's get into iteration. And this is interesting because my sister, who runs a college data science division, the first question she asks is, how do you go through data? And she's asking, do you know how to iterate through data? Do you know how to do a basic for loop? Do you know how to go through each piece of the data? And in NumPy, they have some cool controls for that. So put this as a markdown. There we go, and run it. And it's called the ND-iter. I'm not sure what the ND stands for, but ND-iter for iterator. So before we do that, though, let's create an array or something we can actually iterate through. We'll call it a equals np a range. Let's do something a little funny here, or funky. And we'll do 0, 45, 5. I'm not sure why the guys in the back picked this particular one, but it's kind of a fun one. And if I run that, we do this, you can see we get 0, 5, 10, 15, 20, 25, 30, 35, 40. That's what this array looks like. And that's just from our slice. This is just a slice. That's all that is we created a slice of 0 to 45, step 5. And so we can do with this, we can also do a equals reshape. Let's go ahead and take and reshape this. And since there's 9 variables in there, we'll do a reshape at 3 by 3. So if we run that, whoops, missed something there. That is the A. That really helps. So if we do the A reshape, and we'll go ahead and print that out, we get 0, 5, 10, 15, 20, 25, 30, 35, 40. And then we simply do 4xn, our NumPy iter of A, colon, and we'll just go ahead and print x. And let's see what happens here when we run through this and we print each one of those. It goes all the way through the whole array, so it's the same thing we just saw before. We got 0, 5, 10, 15, 20, 25, 30, 35, 40. So it prints out each object in the array, so you can go through and view each one of these. And certainly if you remember, you could also flatten the array and just do for A and that also and get the same result. There's a lot of ways to do this, but this is the proper way with the ND iterator because it'll minimize the amount of resources needed to go through each of the different objects in the NumPy array. And hopefully you asked this question when I just did that. And the question is, how can I change this instead of doing each object? So first of all, let's go ahead and take my cell type, and we're going to mark that down and run it. And so we're going to work on iteration order C style and F style. Remember C because it came from the C programming, and F because it came from the old Fortran programming. So let's give us a reminder. We'll do a print A, and we'll do 4xn np iterate A. But we also want to do this in a specific order. And you know what? I'm a really lazy typer, so let's go back up here. This is the ND iterator. I knew I was missing the ND part of A. And let's do order equals C. We'll print X on there. And let's do that again. And this time order equals F. There we go. Order equals F. And let's go ahead and run this and see what happens here. And the first thing you're going to notice, our original array, 0, 5, 10, 15, 20, 25, 30, 35, 40. When we do order C, that's the default, 0, 5, 10, 15, 20, and so on. And then when you come down here, you'll see F, order F, is 0, 15, 30. So it takes the first digit of each of the subarrays, or the second dimension, and then it goes into the second one, 5, 20, 35, 10, 25, 40. So slightly different order for iterating through it if you need to do that. So we've covered reshaping, we've covered math, we've covered iteration, we've covered a number of things. The next section we want to go ahead and go over is going to be joining arrays. So we need to bring them together. Let me go ahead and take the cell and make it a markdown. Cell type markdown. There we go. And run that. So let's work on joining arrays so we can bring them together and what different options we have. And let's do, we'll do an NP array 1, 2, 3, 4. We'll go ahead and print. Let's do, oops, first. Well, these arrays aren't that big, so let's just go ahead and keep it all on one line, A. So if we run this, first array 1, 2, 3, 4. Whoops, I forgot that it automatically wraps it when you do it this way. So we'll go ahead and keep it separate and print A. There we go. And let's go ahead and do a B. And we'll do 5, 6, 7, 8. And notice I'm keeping the same shape on these two arrays. Depending on what you're doing, those shapes have to match. And let's go ahead and print second array. Do a print B. We'll go ahead and run that. Oops. Missed something up there. Let me fix that real quick. When I was reformatting it to go on separate lines, I messed that up. There we go, run. All right, so we have first array 1, 2, 3, 4, second array 5, 6, 7, 8. And we'll put a carried return on there. And the key word we use is concatenate. And if you're familiar with Linux, it usually means you're adding it to the end on there. And we're going to do what they call along axis 0. So we have concatenate AB along axis 0. Let's go ahead and run that and see what that looks like. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have an array that is 4 by 2. It has a nice shape of 4 by 2 on here. And if we're going to do it along the axis 0, you should guess what the next one is. We're going to do it along the y-axis. And let's see how those differ from each other. Let's just go ahead and run that. And again, all we're doing is adding in the axes equals 1. So we have our concatenate, we have AB, and then axes 1. Remember a couple things. One, these are the same shape. So we have a 2 by 2, same dimensions going in there. You're going to get an error if you're concatenating and they're not. If you have something that instead of 1, 2 is 1, 2, 3, 4, 5, 6 with a 5, 6, 7, 8. They'll give you an error on there. In fact, let's take a look and see what happens when we do that. Let me just take this. 1, 2, 3, 3, 4, 5. And let's run that. And if we come down here, oh, we got there. It says all the input array dimensions except for the concatenation axes M must match exactly. So it'll let you know if you mess up. That's always a good thing. Let's go ahead and take this back here, and let's go ahead and run that. And so we have our 0 axes, which is 1, 2, 3, 4, 5, 6, 7, 8. And we bring them together. And you'll see a very different setup here when we do it along the axis 1. We end up with, instead of 4 by 2, we end up with a 2 by 4. 1, 2, 5, 6, 3, 4, 7, 8. And that's just changing which axes we're going to go ahead and concatenate on. What I find is when you're talking about the concatenate or the joining arrays, you really got to play with these for a while to make sure you understand what you mean by the axes. It looks very intuitive when you're looking at it. Axis 0, 1, 2, 3, 4, 5, 6, 7, 8. Axis 1 is then splitting it a different way, 1, 2, 5, 6, 3, 4, 7, 8. When you're actually using real data, you start to really get a feel for what this means and what this does. So if we're going to do that, let's go ahead and look at splitting the array. And do that under Markdown and run it. There we go. So you have a nice little title there. And we'll go ahead and create an array of 9. Let's do NP split. We'll do A, and we're going to split it by 3. Let's just see what that looks like. So if we split it, we get an array 0, 1, 2, 3, 4, 5. We get 3 separate arrays on here. Now remember, we're looking at, let me just print A up here. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we can split it into 3 separate arrays. And let's take this, we're going to do this right down here. I'm just going to move the A split down here. Instead of the 3, let's do 4, 5, and put that in brackets. And so when we do it this way, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. I wasn't sure what to expect on that, but we get, when you split an A by 4, 5, you get a totally different setup on here as far as the way it split the array. And to understand how this works, I'm going to change the 5 to a 7. And this will visually make this a little bit more clear. So we had 4 and 5, it went 0, 1, 2, 3, 4, 5, 6, 7, 8. And you see the markers 4 and 5. When we do 4 and 7, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what you're looking at here is the first markers, this is going to go to 4. So there's our first split at the 4, the marker at 4, and then the second split is going to be at position 7. And this is the same thing here. 4, position 5. That's why we're splitting it in those 2 sections. We could also do it 7. Let's just see what that looks like. Run. And you can see I now have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can split it in all kinds of different arrays and create a different set of multiple arrays on here and split it all kinds of different ways. And before we get into the graphs and other miscellaneous stuff, let's go ahead and look at resizing the array. We'll go ahead and take this cell and set the cell as a markdown and run it. Give us a nice title there. And we'll do an array, an NP array of 1, 2, 3, and 4, 5, 6 here. And let's go ahead and just print. Let's go print a dot shape. And we'll go ahead and run that. Whoops, hit a wrong button there. Hit the comma instead of the dot. So we have a shape of 2, 3 here. And this is important to note because when we start resizing it, it's going to mess with different aspects of the shape. And so we'll go ahead and do a print. Scoop in for a blank line. There we go. And let's do b equals np.resize. We're going to resize A And let's resize it with 3 by 2. And then we'll just go ahead and print B and print B period shape, not a comma. We'll run that. Oops, forgot the quotation marks around the end. We'll go ahead and run that, and let's just see what that looks like. So we have 1, 2, 3, 4, 5, 6, our original array, with a shape of 2, 3. And then we want to go ahead and resize it by 3, 2. And we end up with 1, 2, 3, 4, 5, 6, and we end up with the shape of 3, 2. That shouldn't be too much of a surprise. You know, we got 6 elements in there. We can resize it by 2, 3 was the original one, and then we're actually just reshaping it is how that kind of comes out as when you resize it like that. But what happens if we do something a little different? And let's go ahead and just take this whole thing and copy it down here so we can see what that looks like. And instead of doing 3, 2, remember last time I did the, to reshape it, I messed with the numbers and it gave me an error. Well, when you resize it, you don't have to match the numbers. They don't have to be the same dimensions. So we can, instead of going from a 2, 3 to a 3, 2, we can resize it to a 3, 3. So let's take a look and see how it handles that. And when we come down here to 3, 3, we end up with 1, 2, 3, 4, 5, 6, and it repeats 1, 2, 3. So it actually takes the data and just adds a whole other block in there based on the original data and repeating it. All right, now at this point, we've been looking at tons of numbers and moving stuff around. What we want to go ahead and do is get a little visual here, because that certainly you can picture all the different numbers on there. But let's look at histogram. Let's put this into a histogram. Let me go ahead and run that. And to do that, we're going to use the matplot library. So from matplot library, we're going to import pyplot as PLT. And that's usually the notation you see for pyplot. So if you ever see PLT in a code, it's probably pyplot in the matplot library. And then the guys in the back did a nice job, and gals too, guys and gals back there. Our team over at SimpliLearn put together a nice array for me, 20, 87, 4, 40, 53, with a bunch of numbers. That way we had something to play with. And what we want to do is we want to do plot the histogram. Now remember, a histogram says how many times different numbers come in. And then we're going to put them in bins. And we have bins 0 to 20 to 40 to 60 to 80 to 100. You might, in here with the matplot library, they call them bins. You might hear the term buckets, where they put them in buckets. That's a really common term. And then we want to give it a title. So the way it works is you do your plt.hist for histogram, your plt title, and your plt show. And we're doing just a single array in here in the NumPy array of A. And let's go ahead and run this piece of code. Take it a moment to come out there. It says figure size, so it's generating the graph. And you can see we have, and let's just take a look at this. Let me go down a size. There we go. Okay, so now we can see what we're taking a look at here. So between 0 and 20, we have 3 values. So we have a 20 here, we have a 4, and a 11, and a 15. 0, 1, 2, 3. It's actually 4 values, but they start at 0. So remember, we always count from 0 up. And from 20 to 40, we got 20. So it's 1, 42, 3, 4, 5, 6. And so you can see in the histogram, it shows that the most common numbers coming up is going to be between the 40 and 60 range, least common between the 80 and 100. This looks like an age demographics is what this looks like to me. And you can see where they would have put it in the buckets of different age groups, which would be a nice way of looking at this. Histograms are so important and so powerful when you're doing demos and explaining your data. So being able to quickly put a histogram up that shows what's common and how it's trending is really important. And using that with a NumPy is really easy. And you know what, let's take the same data, and I want to show you why we do bins, or why we have buckets of data. I'm used to calling it buckets. Why we have bins. Let's do it instead of by 20, let's do it by tens and see what happens. And what happens when you do it by tens is you miss out on you can see a nice curve here on the first one, and on the second one it looks like a ladder going up and a plummet, a ladder going up and a plummet and a ladder going down. So the first would be more indicative of an age group, and the second one would be what you would get if you divided incorrectly. You wouldn't see the natural trend of, I don't know what this would be, maybe how much food they eat. Hopefully not, because I'm in 50, so I'm right in the middle there, which means I eat a ton of food compared to everybody else. But it's some kind of demographic. Maybe it's mental, maybe it's knowledge, because as we hit a certain point, then we start losing, our marbles start leaking out or something. So you start off knowing something, and then as you get older, you grow more. But you can see here we lose that. You lose that continuity in the thing if you split the histogram into too many bins or too many buckets. And if you actually plotted this by the individual numbers, it would just be a bunch of dots on the graph and wouldn't mean a whole lot. And we've looked at graphs. There turns out are a ton of useful functions in NumPy. I'm sure there's even new ones that aren't going to be in here. But let's just cover some important ones you really need to know about if you're using the NumPy framework. One of them is line space function. This is generating data. So you have a line space, we have 1, 3, 10, and when we do that, we end up with 10 numbers. So if you count them, there's 10 numbers. They're between 1 and 3, and they're evenly spaced. We get 1, 1.222. But these are all, there's a total of 10 here, and it's right between the 1 and 3 range. That can be, there's a lot of uses for that, but they're probably more obscure than a lot of the other common NumPy arrays set up. Then a real common one is to do summation. So we'll do summation where you do, in this case, we create a NumPy array of two different arrays, 1, 2, 3, or two different dimensions, 1, 2, 3, 3, 4, 5. And we're going to sum them up under axes 0, which is your columns. And if you remember correctly, columns is the 1 plus 3, 2 plus 4, 3 plus 5, so we have 3 columns. And if we change this, we'll just flip this to 1. We get 2 numbers. So we get 1, 2, 3 all added together, which equals 6, and 3 plus 4 plus 5, which equals 12. We'll set this back to 0. There we go, since we're looking at axis 0. And these probably could have been, some of these could be underneath our math section. Square root and standard deviation, two very important tools we use throughout the machine learning process and data science. And simply we take the NP array, we have again the 1, 2, 3, 4, 5, 6, 3, 4, 5. I don't know why I need to keep recreating it, I probably could have just kept it. But we can take the square root of A. So it goes through and it takes the square root of all the different terms in A. And we can also take the standard deviation, how much they deviate in value on there. And there's a rabble function. We can run that. And NP array is x, we're going to do x equals, hey, we changed it from A to x. X equals rabble. And this sets it up as columns. So we have 1, 2, 3, 4, 5. This is all columns on here. Very similar to the flatten function. So they kind of look almost identical, but we also have the option of doing a rabble by column. And then another one is log. So you can do mathematical log on your array. In this case, we have 1, 2, 3. And we'll find the log base 10 for each of those 3 numbers. And there's a couple of them. You can't just do any number here after log, but there is also log base 2. Log base 10 is pretty commonly used on here. We'll go and run that. There we go. Before we go, let's have a little fun. Let's do a little practice session here on some more challenging questions. So you start to think how this stuff fits together. Right now we just looked at all the basics and all the basic tools you have. So let's do some NumPy practice examples. And let's start by figuring out how do you plot, say, a sine wave in NumPy. What would that look like? And so in this project we wouldn't have to do this because I've already run these. But we'd want to go ahead and import our NumPy as NP and import our matplot library pyplot as PLT. So we get our tools going here. And then we'll break it into 2 sections because we need our XY coordinates in here. So first off, let's create our x coordinates. And our x coordinates we're going to set to an A range. And we want this A range, since we're doing sine and cosine, it's going to be between 0 and 0.1. And then we use our NP, and we actually can look up NumPy stores pi. So you have the option of just pulling pi in there directly from NumPy. It has a few other variables that it stores in there that you can pull from there. But we have NumPy pi. And we generate a nice range here. And let's go ahead and run this. And just out of curiosity, let's see what x looks like. I always like to do that. So we have 0.1, 0.2, 0.3, 0.4. So we're going 0 to, in this case, 9.4, 3 times NumPy Pi. Remember, pi is like 3 point something, something, something. So that makes sense. It should be about 9. And we're doing intervals of 0.1. So we create a nice range of data. And then we need to create our y variable. And so y is going to simply equal np, or numpy.sign of x. And then once we have our x and y, and if we print, let's go ahead and just print y. See how that, we'll do this. Let's do this so it looks print x, print y. So we basically have 2 arrays of data. So we have like our x-axis and our y-axis going on there. And this is simply a plt.plot, because we're going to plot the points. And we'll do x comma y. And then we want to actually see the graph, so we'll do plot.show. And we'll go ahead and run that. And you see we get a nice sine wave. And here's our numbers 0 through 9. And here's our sine value, which oscillates between -1 and 1 like we'd expect it to. Then for the next challenge, let's create a 6x6 two-dimensional array and let 1 and 0 be placed alternatively across the diagonals. Oh, that's a little confusing. So let's think about that. We're going to create a 6x6 two-dimensional, so the shape is 6x6, two-dimensional array, and let 1 and 0 be placed alternatively across the diagonals. Now, if you remember from lesson 1, we can fill a whole NumPy array with zeros or ones or whatever. So we're going to do np, create a NumPy zeros, and we're going to do a 6x6, and we'll go ahead and make sure it knows it's an integer, even though it's usually the default. And just real quick, let's take a look and see what that looks like. So if I run this, you can see I get 6x6 grid, so 6x6, 0, 0, 0, 0, 0. Now, if I understand this correctly, when they say 1s and 0 placed alternatively across the diagonals, they want the center diagonal, maybe that's going to stay 0 all the way down. And then the next diagonal will be 1s all the way across diagonally. And then the next one 0s, the next one 1s, and the next one 0s, and so on. Hopefully you can see my mouse lit up there and highlighting it. So let's take a little piece of code here. And we'll do z1 colon colon 2 comma colon colon 2 equals 1. And wow, that's a mouthful right there. So let's go ahead and run this and see what that's doing. And so what we're doing is we're saying, hey, let's look at, in this case, row 1. There's 1. And then we're going to go every other row 2. So we're going to skip a row. So skip here, skip here, skip here. So we're going down this way. And we're going every other row going this way. It's hard to highlight columns. So you can see right here where we're not touching each row, like this row right here is not being touched. Okay, so we're going to start with row 1, and then we're going to skip a row and another one, and so we're going every 2 rows. And then in every 2 rows, we're looking at every 2, starting with the beginning. That's what this thing blank means. So we're going to start with the beginning, and we're going to look at all of them, but we're going to skip every 2. So starting with row 1, we look at all the rows, but we do it by 2 steps. So we go 1, skip 1, 1, skip 1, 1, skip 1, 1. If you left this out, it'd do every one. This would just be 1s. In fact, let's see what this looks like. If I go like this and run it, you can see that I just get 1s. So this notation allows us to go down each row, row by row, and we're going to do every other row set up on there. And so if we're going to start with row 1, we also, Control Z, try that. There we go. We'll start with row 0. Again, we're going to go each row, step 2. So we'll start with row 0, and we'll go every other row. And this time we'll start with 1, column 1. And again, we go every other one going down. That's what that step 2 is. Skipping every other one. We're going to set that equal to 1. So let's see what that looks like. And you can see here we get our answer. We get 0, 1, 0, 0. But it has the 1s going in diagonals on every other diagonal and 0 on every other one. A little bit of a brain teaser, that one, trying to get that one to work out. So you can see how you can arrange your rows, and here's your step and your different access on there. And then the next one is find the total number and locations of missing values in the array. The first challenge is to create some missing numbers. So let's create our array Z. We're going to do numpy.random.rand 10, 10. And before we do the second part, let me just take this second part out. And let's just see what that looks like. So let's run that. And there we go. So we have a 10 by 10 random array. It randomly is picking out numbers. And next, we want to go ahead and take our random integer size equals 5. And then we're going to do a random 10 size equals 5. So in the Z, we're going to select a number of random spaces here and set them equal to null value. And let's go ahead and run that so you can see what that looks like. And if we look at the array, we've created 1, 2, 3, 4. There should be a fifth one in here. My eyes may be failing me. So we've created a series of, because 0 to 5, 0, 1, 2, 3, 4. So we got 5, there are different null values on here. And this is kind of a neat notation to notice that we can generate random integers, size equals 5. So this generates 5 by 5 miniature grid inside of this to tell it where to put the nands at. So that's kind of a cool little thing you can do. And then we want to look up and see how many null values are in there. And this is simply just np is nan of z. Simple. So if it is nan, then we want to sum it up. So we're going to sum up all of the different null values on there. And let's do one more feature in here, which is really cool. Let's go ahead and print the indexes. So np argware np is nan of z. So we're going to create our own another np array. And let's run this, and we'll see here that it comes up with the 4 indexes. So we did count 4 of them up there. It tells you where they are, 1, 9, 2, 0, 4, 6, 5, 4. And then let's go ahead and run this again. Run, there we go. This time I got 5. That's what we get for random numbers. Another fun one that I always like to do, it's very similar because we have np is nan z dot sum. So we're summing the number of nans. And we can get the indexes and you can reshape the indexes. But you can also just do, we'll do an inds where np is nan of z. And let's just print, that. Print inds. Let's see what that looks like. And it's very similar to what we have. We have 0, 1, 3, 0, 6, 3, 8, 6, 9, 3. But I've split it into 2 different arrays. So we have our x and our y kind of coordinates going there. And what I can now do is I can now do z inds equals. And at this point, you can also, instead of getting the sum, you can get the means or all the numbers and that kind of thing, or the average as it is. So that'd be one thing you could do, and you can pick out the average. That's very common in data science to get the average and just use that for a value. But we'll go ahead and just set it to 0, and then let's go ahead and print our z and run that. And you can see when we come down here, we have wherever there was a null value, it is now 0. And you can set this to whatever you want. This is another way to replace data or help clean data up, depending on what it is you're doing. So, wow, we covered a lot of stuff. So quick rehash going over everything. We went into there, we looked at array manipulation, changing the shape, how to switch that around. We even had the flatten down there, which remember we have another command lower that's similar. We could change the order by F. Remember F stands for Fortran, very strange connotation, but there's C and F. C is the standard, and F switches it to a different order. To be honest, I usually have to look it up because I almost never use F, but when you need it, you're like, oh my gosh, what was the other order? Just do a quick Google. So we talked about reshape, making sure that the dimensions are the same. You don't want to have like something that has 12 objects in it and reshape it to 11 and 5 because it doesn't work. It doesn't divide into 12. We can transpose, so we can switch them. So we can go from a 4 by 3 to a 3 by 4. Oops, I did that the other way around. 3 by 4 to 4 by 3. We covered reshaping the array. We did the roll the axes. You can do some weird things with swapping and rolling axes and transposing the numbers. We dug a little bit into the arithmetic. So we talked about adding, we talked about subtracting, multiplying, dividing. And at this point it's so important we just look up the NumPy mathematics. And you can see here they have just about everything. Your trigonometry, your hyperbolic functions, rounding, sums, products, differences. There are so many, all your different miscellaneous mathematical connotations. So, Google it, go to the main NumPy page and look at the different setups you can do on there. So we covered that. And we did slicing, how to break it apart. We did iterating over the array. We covered joining arrays and how to concatenate. Remember, concatenate just means add on to it. So in this case, how are you adding B onto A is how you'd read that. From Linux, you should catch the concatenate because that's used regularly there. Splitting the array, we talked about how to split the array in different ways. So you can split it in array of arrays, all kinds of different ways to split the array up. How to resize it. And remember, resize does not have to have the same shape, but if you resize it, it will take the data and begin at the beginning and add new rows on if the size is bigger. If it's smaller, it truncates it. It just cuts the end off. We looked at how to do a histogram and how to plot that. We mentioned buckets or bins, as they call them in PyPlot. And then we covered a lot of other useful functions in NumPy. We talked about the line space setup for doing numbers in a series, how to sum the axes up. Again, that's part of the mathematical formulas there that we looked at. There's a sum, there's also means and median. All of those you can compute in NumPy. And you can also do the square root and standard deviation. The ravel function, very similar to the flatten. To be honest, I almost always just use the flatten, but the ravel has its own kind of functionality that it does. And then we went into some NumPy practice examples. We challenged you to create a sine wave in NumPy and how to do that. We're kind of looking for that A range. Remember how we do the A range, and you can have your beginning value, your end value, which they did as 3 times pi, NumPy pi, and we're going to do intervals of 0.1. And then y just equals the NumPy sine of x. There's our math from the math page we were just looking at. Remember that? It's right at the top. And finally we went down here. We had this kind of a little brain teaser, how to do diagonal zeros and ones, playing with the different connotations of the NumPy array. And then we did a random size, and we played a little bit with with the null values, playing with null values. If you're doing any data science, null values are like a headache. What do you do with them? Big sets of data, you get rid of them. Small sets of data, you have to factor something in there, like figure out the average or the median there, and then replace it with that. So with that, we want to go ahead and wrap this up. And I want to thank you for joining me today.